Okay, hey there guys. Today we're going to talk about three-dimensional vectors. Now, a three-dimensional vector is pretty similar to a two-dimensional vector, except it has one more component in the z direction. So again, we denote a vector as being the variable with an arrow over it, and then we just write down each component. So let's say we wanted a vector that was, let's say, 3i plus 5j plus 2k. So how would we graph this, okay? How would we graph this? So let me first make our little three-dimensional plane. Okay, so this is R3, or our three-dimensional plane, and basically the same idea of graphing this is the same way that let's say let's denote. We'll say that this is X, this is Y, and this is Z. You know, you can flip these around and all that stuff. It doesn't really matter how you label your axes, but so let's say, so we graph it the same way. We know that we have to go out positive 3. We'll say this is negative y and this is negative x, but and this is negative z. So now all we do is we go out 3 in the x direction. Let's say that this is 3, and now we go 5 in the y direction. Let's say that's out here, and then we go 2 in the z direction, so it should be coming out like right here in three-dimensional space. Okay, and now this is gonna, let me project this if I can. That's a very bad projection, but the same idea holds as when you're you're drawing these vectors. You basically look at what your vector is and you just go in each direction. Now, you're probably asking me, well, you know, a vector has to have a magnitude and a direction. Obviously, this has a direction, but how are we going to tell the magnitude? Well, we'll use Pythagorean theorem again, but this is the Pythagorean theorem that will work in all dimensions, and this is another video I'm going to show at a later date, which will prove this, that Pythagorean theorem can be taken to higher dimensions. Typically we use Pythagorean theorem in 2 dimensions with right triangles, but it actually turns out that you can take it to higher dimensions, and it will hold as many dimensions high as you want. So let's, for symbolic reasoning, let's take our vector. Let's say our three-dimensional vector is equal to xi plus yj plus zk, denoting that, you know, these constants will be in that sort of direction. So now if I wanted to find the magnitude of these things, all I would have to do is, and we denote magnitude by this, by 2 bars. That's the magnitude of a vector, and it's just based off what I have up here. It's just x squared plus y squared plus z squared. So this is how you can, you know, denote vectors in higher dimensions. Now, let me just quickly go over. See, I'm sure that, you know, you're thinking, okay, well, if I have a vector here, let's say I wanted to take it to 4 spaces, all I would just have to do is be like xi plus yj plus zk plus, let's just say, wn or something. Let's just say these are placeholders, right? And this is a no-no. You cannot do this because it's because of these guys. These guys, I, J, and K, these are special variables. These have been reserved. So technically you can only write vectors up to a third dimension with these guys. You can't add on this at all. So you can write two-dimensional, well, you can write one-dimensional vectors too. You can write one-dimensional vectors, you can write two-dimensional vectors and three-dimensional vectors, but higher than that you can't. But this is what I have to say. Just because you can't write it in this form doesn't mean they exist. We can represent them by matrices and also by other methods, but that will be in later videos. So basically what you should get out of this is that if you want to denote vectors in 3 dimensions, that they have to have an I, J, and K component, and that if you want to find the magnitude, it's just Pythagorean theorem over again, just added to that. The only thing added is that instead of a squared plus b squared, you add the third component squared as well, take the square root of that, and that will be the magnitude of your vector. Okay, so that's going to be the end of the video. Thanks, guys.